Hey guys, make sure to subscribe to our channel, Eigenbros, and at Twitter, @Eigenbros. So today what we're going to do is we're going to go ahead and derive the arctangent of the hyperbolic arctangent of x. So first off, we're going to start with the definition of the hyperbolic sine and hyperbolic cosine. So I'm going to kind of go through these quickly, but this one, in terms of the exponentials, is going to be e to the x minus e to the minus x over 2. This is going to be e to the x plus e to the minus x over 2. And you can get these from Euler's formula, which is just e to the ix equals cosine of x plus I sine of x. And if you arrange those in terms of sine, just set the I to vanish, set it equal to 1 if you want, and then you'll get these values here. So now I want to rewrite our tangent. And of course, when we find the inverse, so it should be tangent of y, since this is the inverse of that. And it should give us, let's see, so this divided by this, I'm going to change the x's into y's. It's going to be e to the y minus e to the y over e to the y plus e to the y. So now I'm also going to simplify this by factoring out a e to the minus y. So e to the minus y over e to the minus y. And then it's going to be e to the 2y minus 1 over e to the 2y minus or plus 1. Of course, these will cancel away. This equals x. So now what I'm going to do is I'm going to go ahead and solve for the y here. And I'm going to multiply this e to the 2y plus 1 on one side. So it's going to be e to the 2y minus 1 equals x e to the 2y plus 1. I'm going to distribute out that x. So it's going to be x e to the 2y plus x. I'm going to move the e to the 2y's to one side. I'm going to use the minus 1 to the other side. So then we're going to get e to the 2y minus x e to the 2y. That's going to equal x plus 1. Factor out e to the 2y. So we're going to have e to the 2y 1 minus x equals, I'm going to flip these, 1 plus x, and I'm going to divide by 1 over x on each side, or 1 minus x on each side, and that's going to give us e to the 2y equals 1 plus x over 1 minus x. Of course, we can take the natural logarithm on each side, and we're going to get 2y equals ln of 1 plus x over 1 minus x. And I'm going to divide by 2. So we're just going to have 1/2, y equals 1/2 ln of 1 plus x over 1 minus x. And this here is equal to the inverse hyperbolic tangent of x. So now we have a new form of the hyperbolic tangent of x in terms of ln's, the natural log. So now I'm going to rewrite this hyperbolic tangent of x dx integral as 1/2 the natural log of 1 plus x over 1 minus x dx. And now for the logarithm property, we know that we can change this division into a subtraction. So it's going to be 1/2 the integral of ln of 1 plus x minus ln of 1 minus x dx. And I'm going to go ahead and just take the integral of these. Of course, we know that the inside, we know that the derivative of ln, so on the side, I know the derivative of, or I'm sorry, the integral of ln of x dx is just going to equal x ln of x minus x. You can solve that yourself if you don't believe it. So then what's going to happen is we're going to go ahead and just take the argument, since it's going to be 1/2 out here, and we're going to have the argument, which would be x in this case. And for us, it's 1 plus x. Ln of x, or ln of 1 plus x, minus 1 plus x. Okay? And then this one's got a minus sign, so really we need a u sub here if we want to be proper, but we're just going to skip the u sub and just do it mentally. So there's going to be a minus sign that comes here and takes care of that minus, and we're going to get 1 minus x ln of 1 minus x minus 1 minus x. And then of course this is plus c, our constant. Now we're going to go ahead and, so let's take a look here. So we'll go ahead and get rid of these guys. So this is going to be negative 1 minus 1, so that's going to be negative 2, negative x plus x, so the x's will go away. We'll just have the constant 2. We're going to go ahead and distribute things out, so it's going to be 1/2 ln of 1 plus x ln of 1 plus x. So I'm going ahead and distributing out the 1/2, and then I'm also distributing the ln of 1 plus x to the 1 plus x here. And then I'm going to leave this constant towards the end. So then this is plus 1/2, and there should be a 1/2 here as well. Sorry, I'm going a little fast, just trying to keep this under time. We're going to have ln of 1 minus x ln of 1 minus x. And then, of course, we had the minus 2. So minus 2 divided by 1/2, that's just 1 plus c. We'll just call this c2. This is c1, a new c. This is just a constant, doesn't matter. Now let's go ahead and combine. So we're going to use our logarithm properties once again. We're going to combine things that go together. So this one is going to combine with this. This is going to combine with this. So it's going to be this to this, this to this. So we're going to have 1/2 ln of 1 plus x, 1 minus x. So these are multiplied together. So 1 plus x multiplied by 1 minus x, we're familiar with that just being 1 minus x squared. And then 1/2 x ln of 1 plus x. Since there's a minus sign, it's going to be divided. This is going to be plus 1/2 x ln of 1 plus x divided by 1 minus x plus c2. Now, if we look here, this 1/2 x ln of 1 plus x over 1 minus x is the same thing as our hyperbolic tangent function, as we've discovered here. So then we can just rewrite our final answer. I'm going to rearrange some things. It's just going to be x inverse hyperbolic tangent of x plus 1/2 ln of 1 minus x squared plus c. I'm just going to drop the 2, and there is our final answer. So make sure to subscribe to Eigenbros, and also make sure to subscribe to our Twitter. Follow our Twitter at Eigenbros, and thanks very much.